what we're trying to do here is see how we can use 3D printing, specifically stereolithography or SLA, to replace some of the standard practices in IC fabrication and packaging specifically. So what you can see here is a microscope view of a lead frame with a die attached to it. And typically you would have this die attached to the lead frame, and then it would go through an encapsulation process where you put a mold on it, do sort of injection molding. And what we're trying to do is see how we can use 3D printing to fix some of these problems and make the process more robust, more reconfigurable, and lower cost as well. So what we have now, we have this loaded into our 3D printer, our SLA printer. So we see we're going to project light in this certain area, and it's going to cross-link and expose these polymers, which is going to harden them. So it's going to layer by layer print these encapsulations on top of the packages. So it's going to expose it, and it's using a DLP technology to expose the polymers to create a single layer. So these layers right now are 50 microns, so it's going to expose for 10 seconds with a DLP projector. And then you can see over here, after it's finished exposing, the build plate is going to lift up and it's going to prepare for its next layer. Here are some finished products right here. You can see a standard encapsulation where we just have a rectangular shape, something that you would typically have for IC encapsulation. And then we can get more creative with it, and we can print these dome-like structures or lenses.
So I think as far as we're aware, we're the first people in the world to combine inkjet printing with stereolithography. To put in perspective, if you look at your typical circuit board, right, you have all these chips, and this is the black epoxy that we're actually replacing with this orange material in this case. All your chips have them, they're protective, and they're non-functional. But as you see from the demo pieces that we showed earlier, we can do just a standard encapsulation as well, but we add functionality to it. There's a variety of functionality that you can add, and while the demo here is orange, we have clear, we have black, and we have a variety of other properties such as shape memory polymers that kind of remember the state they were printed in for folded electronics, or high temperature applications with certain materials.